With these system word problems, you have to do three things. We're going to build two equations based on translating the words into equations. Here we see that 2h plus 3f is equal to 1700. I'm picking h for hamburger and f for fries. This one's a little tricky. Hamburger is equal to f plus 50. It would be very easy to mix that up and say f is equal to h plus 50, but you have to remember that the hamburger has more calories, which makes sense to real life. That's the second thing. We've now translated two equations. The third thing is to pay attention to the last line. When they ask for the number of calories for a hamburger, we know that we're solving for h. So it would be tempting to just start here and plug in h is equal to this and do some substitution. In the long run, though, that would create extra work because that would solve for f. And we know from the very last line here that we want to solve for h. So if it was me, I would probably change that a little bit, and I would rearrange this equation to say f is equal to h minus 50. And now I can take what f is equal to and plug it into this top equation. So this next one, let's consider people. 202 people total, 2 per this tent, and 4 per this tent. So I will create some variables here for 2 and 4 person tents, and I will set up my equation like this. This is my people equation. Each equation tells me, or each part of the equation tells me how many people go in this tent, how many people go in that tent, how many people total. Then my other equation is just how many total tents are there. And the only thing I'm given is 60. So I can just say that x plus y is equal to 60. This equation is strictly the number of tents. So it doesn't matter how many people go in them, we can just say x and y because we're counting tents instead. People equation, tent equation. Last step, let's look at the last sentence here and figure out what they're asking. How many of the tents were two-person tents? So they want to know what is x. So let's solve this carefully to isolate x. If I take this bottom equation and solve it for y, I can substitute this into the earlier equation. That'll look like this. I'm going to use parentheses to show substitution. I have to distribute the 4. Then I'm going to combine like terms. I'm going to move the 240 to the other side. Everything now is negative. I'm going to divide everything by -2. And x is equal to 19. C. So with this one, I'm going to have two equations, the money equations and the total pounds equation. So we'll say z pounds plus c pounds is going to equal 108. And then $1.69 for zucchini and 99 cents for cucumber is going to equal a total of 150.32. So the top equation, I include pounds, pounds of this, pounds of that, pounds total. The bottom equation is price per pound, total price. If you did this one step at a time, you'd be able to rule out the z plus c. The totals were wrong for a and d. And then if you look at the other equation, they just mix up which variable goes with which letter. So b had it right. So we have two equations, the points equation. So that's going to be 30e, E for easy puzzle, plus 60h for hard puzzle is equal to 1950 total. And my other equation is just going to be the total number of puzzles. So E plus H is going to equal 50 because that's my total here. Then you have to pay close attention to what they're asking for. They want to know about the hard puzzles, so they say solve for H, which tells me I need to get rid of all of the E's and have an equation with just H's left. So why not take this second equation, rearrange it a little bit, and then I can substitute. Then at this point, I'm going to distribute the 30. I will combine like terms. Then lastly, I'll divide by 30 on both sides. And the answer is 15. This one I'm going to have a calorie equation and a grams equation, like a mass equation. So that's a little bit tricky, but these three are about calories. So I will say 4P for protein plus 9F for fat is equal to 110 calories total. And my other equation is just going to be the protein plus fat, how many grams of each, is going to be 15 grams total. So if you look at fat per gram and protein per gram, and total is 15. The last line tells me that I'm looking for how many grams of protein. So in other words, I'm solving for P. So the first step would be to get this bottom equation looking like this so that I can then substitute, which will look like this. Then I'm going to distribute the 9. Then I have to combine like terms. Then I divide by -5. And P is equal to 5. So this one's not quite a systems problem. I mean, we have some of the stuff there. Like we have our money equation, how much per pound, how much per pound, how much total. But instead of the second equation, they instead tell us one of the values. That for milk, we can plug in a 2. And then we can directly solve for bananas. So it's a little bit shorter than a typical systems problem. So we substitute the 2, and we have choices here. I might choose to multiply everything by 100. That gives me 150 plus 15b is equal to 225. That way when I subtract 150 from both sides, I have 15b is equal to 75. You could do it with decimals, by the way, but this way works too. And b is going to be equal to 5. We have a money equation, $6.50 for a salad, $2 for a drink, $836.50 total. Then we have a total equation. Some number of salads plus some number of drinks is equal to 209. We could use substitution again, but let's just double this equation. 2s, 2d, and 209 becomes 418. This allows us to use elimination. If I subtract all 3 columns straight down, I end up with 450 for a salad. The drinks go away. And here, I'm left with 418.50. If I divide that by 4.5, I get 93. And there's our answer. Let's jump to Systems Word Problems 2. We have our money equation, 4 for a novel, plus 1 for a magazine, $20 total. Everything there was money. Then we have our total equation, some number of novels plus some number of magazines, total of 11. They want to know novels. So this one is already set up for elimination. If I subtract all 3 columns straight down, my m's will go away. 4n minus n is 3n, m minus m is gone, and 20 minus 11 is 9. So n is equal to 3. Next one, we have a volume equation, 20 for standard plus 30 for cubic, for collectors, is equal to 1870. Right off the bat, that rules out a couple of these. That rules out this one, and well, probably this one too. So we could just jump straight to the answer. But if we wanted to, we could look at the total number of copies of the game. So they tell us what? They tell us there's 75 total, which we can write as S plus C is equal to 75. And we don't exactly see that. But if we wanted to solve for C, we could say that C is equal to 75 minus S, which is what this looks like. And that's why A is the answer. So let's do a yard equation. Hat is 120. Scarf is 300. And that's going to be less than or equal to 1,500 total yards of yarn. And we want at least 2 scarves, so S like this, and H like this. And do we have any requirement for a total? I don't see any. Oops. So this is going to be our answer. It has the correct yards per scarf and hat, and it has the correct inequalities. 16 is D. Next up, given this equation, remember that A is our slope and B is our y-intercept. So we know that our y-intercept, in particular, falls right down here. So B is something like, oh, I don't know, about -8 or so. So if I look at these different equations, this one is not true. B is not bigger than 10. Then if I consider my slope, I am going up here. So my slope is equal to positive. So where is one that has A being positive? And this one A is negative. This one A is less than 0. So this is the only possible one. So how do we write these inequalities? If it says at least 270, then we're going to write 270, and we're going to write less than or equal to. No more than 280, so that's going to mean less than or equal to 280. And they want to know the values total for the parachute, so we're going to multiply everything by 18. So 270 times 18 and 280 times 18. And our range should have jumped a little bit, so this one is no good anymore. That was our original one for one single piece of rope. And which one has the correct inequalities and totals? That would be C. For our money equation, we're looking at 14.99 for screws and 12.99 for nails. And we have $60, so we want to add these together, and it has to be less than or equal to 60. And then what else? That we need to buy both. So if you add them together, it has to be bigger than or equal to 1. And this is the one where I accidentally cut off the answer. But those are my inequalities. The price is less than or equal to 60, and they have to be bigger than 1 when you add them together. So either C or D. Next up, we have $90 for X, so that's 90X, 250Y, and our total is $27,600. That's the money equation. Then we're going to have a total number of tickets. So whatever X is plus whatever Y is equal to 120 tickets. So X plus Y should be 120. That rules out these. And then we don't need to multiply by 120 there, so A is the right answer. Next up, we're looking at linear word problems. These are just interpreting different types of linear equations. So with linear, we always have a starting value or a one-time fee, perhaps, and then we have a rate of change or a per or an each or somehow an increase or decrease per every something. So here 108 is a starting value, so starts with 108 is the right answer. The per hour, per day, those would fall under the slope category. This is a really fancy way by saying estimated increase in inches each year for asking about slope. What is the slope? It's 3. And the clue there was increase each year. Here, the $60 is the one-time fee or the starting value because the company charges you $60 just for showing up no matter what. And then there's a per worker charge of $12, but then there's the number of workers and the number of hours. So $12 an hour is then multiplied by how many workers are on the job site. So what does 12 mean? It's $12 per hour for each landscaper. If you buy more expensive paint, are the number of walls going to change? No. Is the length of each wall or the height of each wall going to change? Absolutely not. Instead, it is this K, this constant value. Even though it says it's constant, that's for that brand of paint. So it might cost this much per gallon of paint or whatever it is. So K is the right answer. So they're asking what is 331.4 in the context of this equation. So that is our starting value or our one-time amount. So at 0 degrees pretty much indicates that this is the starting value. These two, C and D, increase in speed for each increase in temperature would represent slope. So those are definitely not it. And the reason why this one is wrong is because it includes the slope instead of 0, which would be the starting value. This one's tricky because we have a starting value of 2, and then every time t goes up by 1, n goes up by 1. So our answer is just 1. If you plugged in some numbers and you played around with it, you would see that every time you add an additional tea bag to this amount after your starting value, your cups of tea goes up, also by 1. So there's a couple ways to solve this one. There's a lot of ratios built into this equation, a lot of numbers. We have 100 miles per week, and then we have something like 25 miles per gallon, and then we have something like $4 per gallon. And we want to reduce our driving by some unknown amount so that we can reduce our expenditure by $5. So the ones that target 5 are going to be the right answer, because this equation will tell us when we can save $5. So these are not it. Those are about miles, reducing the miles by 5. But our target is to reduce the expenditure by 5. And how do we figure that out? Well, if it's $4 per gallon, and we're at 25 miles per gallon, so these two equations, we're going to use those together. And if you weren't sure which one could be correct, you could pick a reasonable amount of miles and use the insanity test. So if you plugged in, let's say you reduced your miles by something like 25. We're only driving 100, so I have to pick something like that that's reasonable. If I plug that in down here, I would reduce my cost by $4 according to that. My target is 5, so I'm a little off, but that's at least reasonable. If I plugged in 25 miles to this one, well, suddenly I'm looking at decreasing my cost by $156.25. Does that make sense? Not at all. That does not pass the insanity test. So D is the right answer. Here it's 60 per hour plus 10. It has to be less than or equal to 280. So if you start plugging in numbers, you could figure out that after 4 hours it costs 250, and after 5 hours it costs 300, which is too much, so the answer is 4. If you wanted to solve that algebraically, you would just subtract 10 from both sides. 60h is less than or equal to 270, and you would get this value here, 270 divided by 60, which is 4.5, and 4 is the largest whole number because it's only for whole hours. So we have this equation for the total price. It's $15 per ticket plus a $12 one-time fee. Think of it like a processing fee or a service fee. You have to pay it once, and 15 is each additional ticket you pay an additional 15. So T over here on this side was like the total price. This would be your slope, and total amount in dollars for one ticket would be 27, not 12. And for this would be the entire equation for D, so that's why B is the right answer. If we connect these variables, that X is about running and Y is about biking, so these are not it because those are the variables. We're looking for the total number of minutes spent doing both, so we should add them together, total. Linear word problems 2. We have depreciating at a constant rate for 12 years. So over 12 years it goes from 32,400 to 0. So we are losing $32,400 in value over 12 years. So I can divide that by 12 to find out how much it depreciates each single year. And that is $2,700 per year. And I want to know how much is it worth 4 years after it's purchased. So I take my 32,400 and I subtract this depreciation rate times 4. And that is where you get 21,600, because that's how much is left. Which should be about a third of the way if you're thinking in big terms, so that's a reasonable guess, even if you just guessed. So we went from 4 million to 1.9 million across 13 years. So if we went down 2.1 million over 13 years, it looks like they multiplied by 10 just to get rid of the decimal, so they had 21 over 30. And that is going down, so we're looking for a negative 21 over 30, and that tells us the answer right here. Our starting value is 4 million, and we are depreciating by this rate. Not depreciating, decreasing. So our startup company had 8 initial employees. That's going to be our B value because that's our startup. That's our starting initial value, our one time. And then there's a rate, 2 per quarter for the first 5 years. So we want to know how many quarters after the company opened. So that's every 3 months they hire 2. So we could say something like y is equal to 2 times x plus 8. 8 comes down from here, 2 comes down from there, and we plug in some number of quarters and we find the answer. And now what are they actually looking for? If an equation is written in this form, what is the value of b? Well, that's just here, 8. So here they tell us the front of the roller coaster rises at a constant rate of 8 feet per second. So I like 8s here. I don't like 15s. And our starting value is 15 feet above ground. So I like this one. So here we have 2 different jobs for an electrician. And the only thing different is 2 hours longer. So we plug that in for H, 75 times 2, and the answer is 150. Both electricians, or both the same electrician is going to charge the 125 upfront fee just for showing up, and then $75 per hour. So that's the only part that's relevant. So if we plug these values into the equation, so we're looking at y is equal to k over x, and we plug in 6 for y, and we plug in 2 for x, what will make this true? The only way to make this true is to have k equal to 12, because 12 divided by 2 is 6. So k is equal to 12. So we could then plug in some of these other ones, just guessing and checking, into this equation and see what makes sense. Is 3 equal to 12 divided by 1? No. Is 4 equal to 12 divided by 1? No. Is 3 equal to 12 divided by 3? No. Is 4 equal to 12 divided by 3? Yes. There's our answer. We have our initial amount, 2,000. That's our starting value. And then our slope is going down by some number k. Well, that's the number of years. It's going down apparently by 61 per year. And after some number of years, it's 48. So this is our starting value. This is our slope here, the negative 61. So it's like b is equal to 2,000 right here. Slope is equal to negative 61. 48 is just a current total. So what does 61 represent? The average decrease in the population per year. That's a key word that tells you we're looking at slope. So for 1 day, a per day cost is a one-time fee. So 80 is equal to our B value. And our 15 cents per mile is our slope. They want to know how many miles was she charged if it was 98. So 98 is equal to 0.15 m plus 80. So 18 is equal to 0.15 m. If I wanted to multiply by 100 to get rid of the decimals, I could. So this is going to be something like, oh right, I have to put another 0 there. This is going to be something like 120. Our starting value here, or initial fare, is $3. That's going to be a B value. And this one's tricky because it's 40 cents for a fifth of a mile. So how much does it cost for 1 mile? Well, I could take that 0.4 and multiply it by 5, and it turns out it's $2 per 1 mile, which is an easier slope to use than 40 cents per 1/5 of a mile. So if I build my equation, I can say that $27, the charge for a ride, is equal to $2 times some number of miles plus 3. So 24 is equal to 2m. Our answer is 12. 250 miles per day, that's my slope, so it should be attached to a variable. So that means this one is wrong. And it's the remaining distance after driving for n days. So it's going to be d. We start with our 1,000 and we're subtracting that amount to find out how much is remaining. This one would get bigger, and this one is going to be negative. Distance can't really be negative, so D is right.